So there's 3D printing, which lets you make materials in all unusual shapes and more precise. But it uses up a lot more energy oftentimes than some of the other methods I'll get to, such as casting. Casting is when you make a mold and you simply, eh, simply is there can be complex techniques to it. You pour in the liquid, and the liquid metal and it hardens. With pouring in the liquid, sometimes you can get better temperature control and stuff. Then if you're 3D printing and you have to cool down and expand and heat up stuff, you might also get more solid at once so that you have to worry less about like support structures. You can also make it a lot more cheap because theoretically you can reuse the cast over and over again to some extent. It might crack or eventually or might break, or there might be problems with casting with how would I say it? There might be problems with casting where you have to have inlet valves or something like that in it that you might have to remove or take away. So it's not perfect. 3D printing, because you have to move either a powder or filament over the whole thing, you lose some of the energy because you have to move do all this fine movements and placements. You also have to heat up a little bit of mass quickly, which then cools down, and that can also mean that more energy heat loss is lost heating up that one and radiating it to outside air, for example, than heating up a big solid chunk. It's also less fast because you have to be all this precise movement and stuff. Now, making the cast and casting is the most expensive part, so a solution that some people have talked about, and I want to present here and talk a little about it, is making the cast using 3D printing. There's a couple of ways we can do that. First of all, this cast has to handle very high temperature, or it has to melt away. One way we can make it handle high temperature is to 3D print ceramics, which can handle extremely high temperature. There's a couple ways we can do that. So one way of doing that with 3D printing ceramics is we have the ceramics embedded into a polymer matrix or resin matrix, and then we slowly dip it into, and we slowly print that, and then we heat up, and the polymer disappears, and we're left with the ceramics. Another way we can do it is we can print down more traditional pottery-like ceramics that have water or something or some binder that then we can bake off. A third way is we can use a sand injection, and now we need something solid around it, but if we put sand and sand layers, the sand has some problems. It can obviously not hold the shape well because it's a coarse grain, but it can add extra support. Like if you put a brick on top of sand, the sand can support that brick. So it can be used in places. Another one would be that you can how would I say it? Another one is that you heat up something really high temperature, the powder, using laser or something locally. The fourth and last way you could do this is by using a plastic mold or mold that burns away, but you make it so that it burns away fast on some parts of it, and some parts of it survive to last a little bit. And so an ablative one. This really might be useful, but it's not a reproducible way of doing it. However, if we combine all these techniques, we might be able to get a mixer that is the best of many worlds. The nice thing about sand and granular material is you can recycle it more easily for other molds and take it out. It can also, so if you have a solid thick mold and the support is granular material, it can be something you can recycle very easily. You can also have materials with different heat conducting properties. So sand is more insulating than a thick sheet, but it doesn't hold heat as much, has high heat capacity. This means it doesn't have as much heat itself. So you can customize it so it heats up and cools down in different ways, or has different support in different ones. Also, sand and granular material is less material, and it's less likely to crack in some ways, so you might save cost there. 3D printing, 3D printing with ceramics with resins, with aluminum resins embedded, you do have to burn them off, and you have a limitation with what types of resins and stuff you can do. And you have shrinkage and stuff, which can lead to stress and joints. The granular one doesn't. Baking off, but you can do some of the most precise. The clay one is the least precise, and there's also the least options of stuff you can do. But you might not have the same shrinkage problems and stuff that you have with the 3D resin one, and stresses. Now, on top of that, if you want to get more precise, and you're really worried about 3D stresses of when it shrinks and stuff, or forms a ceramic, there's a couple things you can do. One is you could embed sand or something else to cushion the shrinkage so there's more even pressure around the mold. You could even 3D print it so that there's a plastic mold in it while you're baking it, and the plastic mold eventually comes out, but helps redistribute the stress for a while. So you can have it printed with different resins, and some of the resins bake off, or plastics. Of course, then you want a cheap plastic or something. Or sand. You can also try to develop ones, resins and stuff with different shrinkage rates and baking rates, so it more precisely doesn't have any pointed stresses, so some points might shrink faster than other ones. Another one is better heating and cooling conditions, or you might make it so that you print the first part section, print another section, and so on, and you redistribute that, which was where sand might come in very well, because sand you might be able to remove. To some extent, you might also do the idea that you have a CNC machine. In a CNC machine, it's kind of, or another machine that kind of specifically, how would I say it, drills out a little bit or mines it. CNC machine usually has like a drill bit that rotates and slowly moves layers of material for a more precise one. Another thing you could do is have laser stuff to locally heat up and do stuff. So that is just some of the ways that 3D printing could really help you. Another thing that it could help here is with the thermal regulation I was getting at, so you can cool down different parts of materials at different rates. And that fancy cooling down, heating up, can lead to different crystal structures or strengths and hardness of material at different places. Or you can do it so that there's not different hardnesses and stuff, but flexibilities, or even you can introduce air bubbles, something. Another thing is that you could also combine this with a 3D metal printer, so you can always print some of the metals within it for kind of in-between one. Even though it's not as cheap as casting, this might be able to fill out little things, holes like the inlet valves and stuff, so that's not necessary to really worry about the inlet valves and stuff. Or the parts that you really can't make a good mold, a nice mold for. You could use that, because some parts with complex parts, it's really hard to mold. You could also, with this technology, make molds that are weaker, and then you could just break them off or separate them off. Or with 3D printing, you could potentially combine it so there's more different types of metals. And beyond this, you also have molds that give you pressure control, because they shrink at different rates when heated or cooled. We distribute the forces differently if you press them to get work hardening or other similar effects. Maybe we include magnetic particles in the molds that we can use an induction heater to heat up specific areas with built-in heaters to higher temperature, or that act as heating elements when we put electricity through the whole thing, and we can more precisely deliver electricity, or through heating through certain radio waves or something and how they interact with the material. We could also just more rapidly prototype and figure out the responses of materials under all these different conditions. We could also make materials, molds out of ceramic stuff that let in different gases but don't let the metal in because of different surface tensions and molecular size. And we can use these gases in these precise molds to just harden the surface through nitrogen or something while it's cooling down and forming, leading to new types of metals with a special outer coating or carbon-enriched, or we can oxygen to give them an oxide layer or something like that in more precise ways that we haven't been able to do in the past. Well, thank you very much for listening. Thank you very much for listening. Please like and subscribe. It really helps the channel out. I'm trying to reach 1,000 subscribers in a year and 4,000 watch hours. This is really hard, really help I think into it. Again, thank you very much. Goodbye.